Till now we have done the problems in which we were only concerned about the equilibrium of the charge that you are placing. That means if you had a charge plus q here and if you had a charge plus 9q over here, right? And let's say they are separated by 100-meter distance. The question used to be, where should I place the third charge such that that third charge is in equilibrium? That means the net force on the charge that you are keeping is 0, right? If I keep this charge somewhere here, which has to be closer to plus q, because plus 9q is a bigger magnitude, right? So I could have been able to find out the distance x, and we used to give the answer as x is something 75, 25, whatever it is, right? But now the question is changed. The question is what should be the position of the new charge as well as the magnitude of this new charge such that whole system is in equilibrium. That means the net force on this charge is 0, this charge is 0, and this charge is also 0, right? In the previous case, it didn't matter what sign of that charge was. It could have been positive, it could have been negative, or it could have been any magnitude as well, right? What mattered is the position. At that position, you keep any charge, the net force will be 0, right? Till now. But now they will ask you to have a net force on this as 0, net force on this as 0, net force on this as 0. So here the magnitude and the sign will matter. Okay, let's see how it matters. First, I want to find out the q in such a way that the net force on q is 0, right? Okay, so now let's see that this is q charge. If I assume this as a positive charge, okay, it can be positive or it can be negative. As at a moment I am assuming it is a positive charge. The force on capital Q due to small q is right direction Fq, and force due to 9q is in the left direction. So this is 9q force, right? Both of them have to be equal. So now what I am going to do is I am going to equate these two forces to find out x. My first aim is to find out x. Then we will see what is the value of q such that the net force on these and these is 0. Okay, now force due to 9q on capital Q is kq into 9q upon 100 minus x whole square, and force due to small q on q is kq capital Q upon x square. So we can cancel this q, this q, this q, this q, k and k. So this is 9 upon 100 minus x whole square is equal to 1 upon x square. If I take a square root, it will be plus minus 3 upon 100 minus x is equal to 1 upon x. So this is what you will get. Now let me use another marker. Okay, so now 100 minus x is going to be equal to, let's take a positive solution first. So this is 3x, so 4x is equal to 100. So x is equal to 25 meter. So x is 25 meter, or you can take a minus sign. So this will be minus 3x is equal to 100 minus x. So this is minus 2x is equal to 100. So x is equal to minus 50. So this cannot be a solution. This can be a solution, right? Because this is negative. So x is 25 meter. So this is 1/4 of 100, and this will be 75 meter. This is 75 meter, while this one is 25 meter. Now this small q, this capital Q is in equilibrium now. It doesn't matter what value it can have. Eventually that value will get cancelled out here. See, q and q. It can be 2q also. You can place a 2q charge here. Then also net force will be 0 because that 2q will cancel out. Okay. Now we have to find out the value of capital Q such that the net force on plus q is 0 and the net force on 9q is also 0. And we know that already the net force on this is also 0. So since the net force on all charges are 0, the whole system will be in equilibrium. So let's do that. Let me erase it quickly. Okay, see, let's do that. What is the value of capital Q? See, now what should be the sign of capital Q? If this, the net force on this I am considering is 0, then see, first of all this is plus, this is plus. So this will repel it here in this direction. So I will show here the free body diagram. The force by 9q will be towards left on this q charge, right? This is plus q charge. Now to balance that force, this q has to be negative, because otherwise it will also repel in the same direction. So this has to be negative, so that means it will attract it here. So this should be negative, okay? This is not positive, negative. And let's say that force is Fq. We'll find out the value of Q, correct? Yeah. Okay, so let's do that. Force due to 9Q is K Q into 9Q upon 100 square. This force due to 9Q. What is the force due to capital Q? K capital Q into small q upon 25 square, right? Okay, so now q and q will get cancelled, k and k will get cancelled. This is 9q upon, okay, let's write it as this 9q. This can be written as 25 upon 100 whole square, right? This can be written as 25 upon 100 whole square into 9q is equal to q. So what should be the value of capital Q? Capital Q is 9q by 16. 9q by 16, right? So this is the value of capital Q. And this should be negative. This should be negative. Why? Because I told you already, it is a negative charge. So minus 9q by 16 is the charge. Okay, so this is the charge. Let me again check if it is correct. Kq, Q 9q upon 100 square, Kq Q upon 25 square. Yes, okay. Yeah. Okay, so now we got the value of capital Q such that this is in equilibrium. Now for this value, this charge will also be in equilibrium. Okay, let's check if it is in equilibrium or not. It will automatically be in equilibrium. Let's see. What is the charge on, what is the force on 9q? Let's draw the free body diagram. The force on 9q due to the force on by the q plus q is in the right direction. Because of this capital Q, it is in the left direction. So this is a force due to minus 9q by 16. It is attractive force, right? So now these two forces have to be equal. So let's say what is F plus Q? F plus Q is equal to K 9q square upon 100 square, right? This is F plus Q. Now F minus 9q by 16 has to be equal to this value, right? Then and then only 9q will be in equilibrium. So let's find out that force by 9q by 16 on this. So it is K 9q by 16 into 9q divided by 75 whole square, right? So this will be 81. 9 into 9 is 81. Kq square divided by 75 into 75. Now I can see, to compare this, I should have denominator 100. So basically, what should I do? Okay, there is 16 as well, right? So 16 I will write as 4 into 4. And let's look at this. This is 81 kq square. Can I write 75 as 25 into 3? So this will be 25 into 3 into 25 into 3 into 4 into 4, right? Okay, so 3 into 3 is 9. So this 9 into 9 is 81. Now 25 into 4 is 100, 25 into 4 is 100. So this will be 9kq square by 100 square. Aha. So it is equal, right? K 9q square by 100 square and K 9kq square by 100 square. Both of them are equal. So automatically, you take this net force on Q as 0 by this charge, right? You find out this charge by making the net force on Q as 0, this one. Then automatically the net force on 9Q will be 0. Okay. Yeah, that is how it works. Okay, let's do another question to make our concepts clear. Let's say we have two charges separated by 90 meter. Okay, let's say this is plus q and this is minus 16 into q. This is minus 16 into q and this is plus q. Where should we place the new charge such that the net system is in equilibrium, and also find out the value of that charge, right? Okay, so if I assume that the charge that I am placing is positive, right? Q I am assuming as positive charge. So where should I place it? See, if I place the positive charge here, this guy will repel this guy will attract. So the net force is in the right direction, right? So that doesn't work. Now look here. Here if I place the capital Q, let's say this distance is x, right? So this guy will repel it, but this guy will attract it, and this value of the small q is lesser than the magnitude of 16q. So and it is closer to the smaller magnitude, then this must be correct. Okay, so let's find out this value of x first, so that this capital Q is in equilibrium. Let's do that. If I see the free body diagram of capital Q, the force on this due to this is towards left, Fq, and the force due to minus 16q is in the right direction. Okay. Yeah. Okay, so both of them have to be equated so that you will get the value of x. So let's do that. K q by x square is equal to K 16q into q upon 90 whole square. Yeah, this is not 90 plus x whole square. 90 plus x whole square. Oh, I am finding out the force on capital Q, right? Sorry. I am finding out the force on capital Q. So it will be capital Q, right? So now Q and Q will get cancelled. Capital Q cancel. K gets cancelled. So 1 upon x square is equal to 16 upon 19 plus x whole square. If I take the square root, I will get 1 upon x is equal to 4 upon 90 plus x, right? Okay, with a plus or minus sign. So let's look at plus solution first. So plus solution I will directly write as 4x is equal to 90 plus x. So 3x is equal to 90. So x is equal to 30 meter. So the plus solution is this. And what about the minus solution? Minus 4x is equal to 90 plus x. So minus 5x is equal to 90 and x is equal to minus 90 by 5. Minus 16 meter. So minus sign we will not consider, we will consider this solution 30 meter. So x is indeed 30 meter. X is 30 meter, right? Okay. Now let's find out, let's write it here itself. It is 30 meter. Now let's find out what should be the value of capital Q charge such that the whole system is in equilibrium, right? Let's do. Okay, let me erase that. We'll quickly erase this. Okay, let's do. Now, see, let me take this. Okay, I want to make the net force on this charge as 0. So, of course, if I draw the free body diagram of plus q, the force of minus 16q is being attractive, right? Force of minus 16q is attractive, and the force on capital Q, force by the capital Q should be in this direction. That is only possible if Q is negative. That means I understood Q is negative, right? Okay, so this is the force due to capital Q. Both of them has to be equated. So this will be KQ by KQ capital Q upon 30 square, and now 16Q will be applying a force, that is KQ into 16Q, and the distance is 90 square. This Q gets cancelled, this K gets cancelled. So Q is equal to 30 by 90 whole square into 16Q. So this will be 1 by 3, that is 16Q by 9. This capital Q charge is 16Q by 9 with a minus sign. Why? Because it is a negative. right? So this charge Q is minus 16Q by 9. Okay, now the same thing, if you see the net force on this minus 16Q, it is going to be 0, right? So see, if I write this minus 16Q charge here, the force due to this minus 16Q by 9 is repulsive force, right? So force due to minus 16Q by 9 is in the right direction, and force due to Q is in the left direction. Okay, so the force due to Q on minus 16Q is KQ 16Q upon 90 square, right? Now this is the force due to plus Q. Now the force due to minus 16Q by 9. Yeah, the force due to minus 16Q by 9 is a repulsive force in that direction. So that is equal to, F is equal to K into 16Q by 9 into 16Q divided by 90 plus 30 whole square, that is 120 whole square, right? So we are finding due to this, right? Now these two forces, these two values must be equal, right? These two values must be equal. Let me consider this force. This force is on 16Q minus 16Q, due to which charge? Due to minus 16Q by 9, right? So let's do that here. This force F is equal to 16 into 16 Q square, 16 into 16 KQ square basically, divided by 9. And 120 can be written as 40 into 3, right? And this is 40 into 3 again. So 120 into 120. So right now this is 3 into 3, 9. I want this denominator to be 90 square, right? So what I can do, 3, so okay, let's divide by 4, right? Let's remove this 4 4s are 16 into 10, right? And this is 10. Okay, so this is 30 into 30, that is 16 KQ square divided by, this is 90 into 3 into 3 into 10 is 90. So this is 16 KQ square by 90 square, right? This is 16 KQ square by 90 square. This is also 16 KQ square by 90 square. So this, both of them are equal. So yes, indeed it is correct, right? Okay, you can try this question I have written over here, where this is plus Q minus 49Q, and they are separated by 80 meter. You have to find out the place at which the new charge should be placed such that everything is in equilibrium. Find also the value of that charge, okay, and post that in the comment section. Thank you.